Hello ladies and gentlemen, welcome to my basement shop. My name is Harold. Today I'm going to improve the rigidity of my Emco Compact 8 compound slide, which is notoriously weak. The disc at the bottom is held by a pretty flimsy retaining plate, which is clamped onto the cross slide by two M6 bolts only. I came up with a more stable design with a plate matching the gap between the bottom of the compound slide and the bottom disc. Thus, most of the slide should rest on the plate. The bottom of the cross slide is just an unmachined casting, which is not suitable as a bearing surface. Thus, I machined the bottom surface of the slide parallel to the base of the dovetail. I used the top of the cross slide as a reference and dialed it in parallel to the X and Y axis of my milling machine. Note the slight banana shape of the way. I will probably scrape this in later. The compound slide bottom was mounted on the top half and pretty firmly clamped with the gib adjusting screws. Out of curiosity, I checked the parallelism of the bearing surfaces. Not too bad. The work was centered with a DTI mounted in the Wohlhaupter facing in boring head. I used a tiny razor-sharp boring bar in the head and touched off. The mill had to be run in reverse as the facing was done from outside to inside and the tip of the bar had to point inwards later. Increasing the speed a bit, running in reverse helps. Depth of cut was about 50 microns. This cleaned up the entire surface. Next step was facing the rectangular surface. Touching off. The table was lifted by approximately 50 microns for the first pass. I added another 50 microns for the second pass. And again 50 microns for the third pass. Still, this didn't clean up the entire surface. I left it at this point as I didn't want to take off more than absolutely necessary. The outer areas were perfectly flat, good enough for the application. As the bottom disc is attached to the cross slide only by 3 M6 bolts, I intended to add 3 bolts to stabilize the mount. The bolts should be located approximately on a circle. The radius was determined by a few measurements. The bottom disc was mounted to drill the holes for the bolt circle. The DRO was used to locate and center drill the holes. This didn't look right. Okay, let me rethink this. Accidentally, I based my calculations on a 30-degree angle, which should be 60 degree. So y should be 15 millimeters times the sine of 60 degrees, which equals 13 millimeter. And x should be 15 millimeters times the cosine of 60 degrees, which equals 7.5 millimeters. So let's retry this. Looks better. Drilling to the diameter of M6 steps. I used the quill stop and raised the table until the depth of the countersink was correct. drilling 6.2mm holes for M6 bolts through the disc only, again using the quill stop. The disc was removed and I tapped the threads. They were started under power and finished manually, as I didn't want to take any chances. As I don't have a bottoming tab, I use the finishing tab of a hand tab set to complete the threads. Final test fit looking good. Machining the actual retaining plate was the next step. As the new plate should tightly fit between the bottom disc and the face of the compound slide, I had to determine this distance quite accurately. The dial calipers gave me a good initial estimate. I checked with a 9.70 gauge block stack, which went in. The 9.75 stack was on the tight side. So I went for 9.75 minimum. I used a piece of steel from the scrap bin to make the part. As the material was way too thick, I had to phase off quite some material. To clean up the OD, I had to work very close to the jaws. After checking the clearance, I turned the witness mark as a visual reference and took a light cosmetic cut. Time for some boring work. I started with a center drill, which happened to be a left-hand one. My self-tensioning chuck didn't like that, but it did work finally. The drilled hole was enlarged with a boring bar. I switched to a different boring bar with a different insert, which worked much better. The diameter matched the smaller diameter of the bottom disc. More material had to come off the face for the final thickness of the plate. I noticed a zebra crossing pattern on the face and observed some play in the cross slide. The finish improved after tightening the gib. The thickness had to be measured with calipers, as there was insufficient clearance for a micrometer. Usually the tutorial calipers are quite reliable, and as the measurements were consistent, I could trust the results. The carriage was moved by 0.19 mm using a dial gauge. (14.96 minus 0.19 equals 14.77. Spot on. I took another 0.07 millimeters. And hit the final target of 14.70 millimeters. Time to machine the recess, which will accommodate the bottom disc. The target depth was 14.70 millimeters. That's the thickness of the plate measured before. Minus 9.75 millimeters, which is the measurement taken with the gauge blocks, which equals 4.95 millimeters. The depth was quite critical. I measured it with the depth micrometer and, as before, adjusted the carriage using the dial indicator.
12.6.
Then, at long last, I realized that I messed up a bit, as the bore was way undersized in part. This is clearly visible in the video, but I didn't notice my mistake during the machining process. I should have watched the video. The error was easily corrected, fortunately. This concluded the lathe work, more precisely the traditional lathe work. I left the thickness of the plate slightly oversized and intended to lap the excess material off for a tight fit. I mounted the casting of the compound slide in the four-jaw chuck and centered it roughly. The plate was put on. I applied Brownell's garnet lapping compound on the disc. And used a few drops of WD-40 as a solvent. For safety reasons, I drove the spindle with a sloppy round belt at low speed. The disc was loosely bolted onto the casting so that the retaining plate was still able to spin between the casting and the disc. The process of tightening the bolts and lapping was repeated until the bolts were tight and the parts were still able to move against each other. back to the mill for drilling the mounting holes and milling the pockets. The work was centered in the usual manner. The distance in X between the holes was determined by the T-slots of the Emco lathe. I wanted a bit of length between the holes to support the compound slide and estimated the approximate location in Y. The holes were center drilled and drilled with the camera turned off. Apologies, but I think you have seen me drilling holes, I suppose. I re-estimated the size of the pockets required to accommodate the bolt heads and the spanner. The first pocket was milled with a 20mm carbide end mill. I took very light cuts, didn't want to risk anything. The process was repeated for the remaining pockets. After deburring and cleaning up, it was time to take some measurements to compare the rigidity of the old version versus the new design. I attached a lever to the compound slide and mounted the indicator stand directly on the bottom part of the slide so that it wasn't influenced by the lever. I started with the original retaining plate and the force applied laterally to the sliding direction. I applied force with a block of steel placed onto the end of the lever arm. The measured deflection was 65 microns, quite consistently across several measurements. The measurements were repeated with the compound slide rotated by 90 degrees. I call this the longitudinal position. This time I got 31 microns. Again, the measurements repeated very well. Now the moment of truth. In the lateral position, the deflection was 17 microns, way better than the previously measured 65 microns. In longitudinal mode, I measured 19 microns, also an improvement compared to the 31 microns measured with the original design. Despite a few minor mishaps, I'm really pleased with the little modification. There is a little drawback though. I can no longer read the graduation of the compound slide. This shouldn't be a problem, as it is always possible and probably even more precise to use an external protractor. That's it for today's video. I hope you enjoyed it. Thanks for watching and see you next time.